Welcome to the walkthrough for Assignment 4A. The purpose of this assignment is to deepen your experience using Java's functional programming features and Java's reactive streams. In particular, in this assignment, you'll develop an app that uses the RxJava implementation of the reactive streams specification to obtain, transform, and store images asynchronously in a pool of threads. Like the earlier assignments, the code you write has a GUI and it runs as an Android app. Please use this GUI along with the unit test discussed below to help test and debug your solution. The following resources may be helpful in completing this assignment. Videos on Java Reactive Streams and RxJava appear in my YouTube playlist here, and tutorials on RxJava appear here and here. Naturally, we'll cover all this material in class, which will be available in my YouTube CS253 playlist here. The Image Crawler app is packaged as a project using the latest version of Android Studio. This app is written in both Kotlin and Java and demonstrates many Android capabilities. For the purposes of Assignment 4A, however, you only need to be aware of the following directories: Image Crawler source main Java edu Vanderbilt Image Crawler crawlers, which contains the skeletons you need to fill in as described below, and Image Crawler source test, which contains a set of unit tests that exercise the features you're implementing and are used to evaluate whether you've correctly satisfied this assignment's requirements. To compile this code, you'll need to use the provided Android Studio project. You can run this project by clicking the green Run App button in the Android Studio IDE, which should automatically select an Android emulator to run, assuming you have one created. The app's minimum API is 31, so you need to select an emulator that uses an API greater than or equal to 31. I recommend API 32. If you don't already have Android emulator installed, you can create one by clicking on the AVD Manager button in the Android Studio IDE. You'll need to modify several files containing the skeleton Java code by completing the to-do you fill in here task to provide a working solution. Please don't change the overall structure of the skeleton. Just fill in the to-do tasks and don't delete the to-do tags. In particular, you need to finish implementing the following to-do tasks for this assignment in the image crawler folder: crawlers/rxobservablecrawler.java, where you'll need to complete the to-do tasks and various methods to obtain, transform, and store images. This class uses the observable operators in RxJava to perform an image crawl asynchronously, starting from a root URI. Depending on the parameters used to run the app, images from HTML page reachable from the root URI are either downloaded from a remote web server or read from the local file system, transformed locally, and the transformed results are then stored in the local file system on the Android device. You'll also need to complete the to-do tags in the common/student.kt file to set the type field to include just graduate or undergraduate, depending on which version of the assignment that you're implementing. The bulk of the code for this app is provided in the skeletons. In fact, a complete solution using Java 7 features is provided in the sequential loopscrawler.java file. You'll therefore convert this Java 7-based class to the RxObservableCrawler class that uses RxJava. Your solution should use no loops or if statements in this assignment and instead use RxJava operators and functional programming features. Likewise, there should only be one call to block, or more specifically, blocking get. Your solution will be considered correct if it passes all the unit tests, is commented thoroughly, and addresses my review comments. Skeleton code for this assignment is available here in my GitHub repository. Now that you've set up your GitLab account, you can pull this skeleton code into your repository, read it carefully, and complete the to-do tags. Unit tests in the Image Crawler source test folder are provided to increase our collective confidence that your implementation is working as expected. You'll need to use the Android Studio GUI to run the unit test locally on your computer, as described here. As always, testing only demonstrates the presence of bugs, but not their absence. So please don't rely solely on the unit test to detect problems in your code. Assignment 4A is arguably more complicated than the previous assignments. In particular, the asynchronous nature of RxJava and the reactive style of reactive streams may take some time to get accustomed to. So please start the assignment soon and ask questions in class, office hours, and on the discussion forums. As usual, the app, image crawler skeletons, and unit tests are extensive, though you don't need to understand them all to complete your solution successfully. Now that we've walked through the assignment 4A specifications, let's turn our attention to the skeletons. If you go into the crawlers folder and click on RxObservableCrawler, you'll see the class that you need to fill in. This class, which is called RxObservableCrawler, uses the RxJava observable class to perform a reactive image crawl starting from a root URI. Images from HTML pages reachable from the root URI are asynchronously downloaded from a remote web server or from the local file system, transformed, and then stored in files that can be displayed to the user. Let's start by taking a look at the perform crawl method, which is the entry point into this program. In this particular case, that's going to be used to recursively crawl the given page that's passed as the page URI parameter and return the total number of processed images. And to do this, you'll perform the following steps. You'll use a helper method, which is hopefully pretty clear from looking at the code below, to crawl the page using the specified URL and depth. Then you'll count the number of elements in the observable stream that's returned from the helper method. You'll return 0 if any exception is encountered by using the appropriate exception handling method. That's part of the Reactive Streams API for RxJava. You'll then block to get the result, and finally you'll convert the result to an int primitive. Let's go ahead and take a look at the crawl page async method, which recursively crawls the web page that's identified by the parameter page URI, and then will download, transform, and store all the discovered images that are reachable from that page. The recursion ends when the passed depth is exceeded. So this particular method implementation should use observable operators like just, filter, map, and flat map, and this latter operation should be used to call the images on page and page links async method. And crawl page async should perform the following steps. It should first use a factor method to create an observable that emits this page URI. It then filters out the page if it exceeds the depth or it's already been visited. It'll then map the URL to a page, and finally convert each page to an observable stream of images asynchronously. Let's turn our attention now to the images on page and page links async method, which returns an observable that emits all the images on the page and all the pages that are hyperlinked from it. This particular method should call the images on page links async and images on page async helper methods, and then use the observable operator merge with to merge all the images into a single observable stream. The next method is images on page links async, which will find all the page links on the past page and recursively crawl each page to download, transform, and store all the discovered images. This method should call the crawl page async method defined earlier recursively, and also use various observable operators like from iterable, flat map, and subscribe on to perform the following steps using the RxJava IO scheduler. So let's go ahead and take a look. First, you'll use a factor method to convert the list of page links into an observable stream of page links, and then you'll apply the flat map concurrency idiom to crawl each page asynchronously and emit a stream of images that are downloaded and transformed concurrently via the IO schedule that's passed. Let's go take a look now at images on page async, which will find, download, and transform all the images on a given page. And naturally, it'll do this all asynchronously. This method should call the get page elements as URLs helper method, get or download image, and the transform image helper methods in conjunction with the observable operators from iterable and flat map. And it will perform the following steps. It'll first use a factor method to convert the list of images in the page into an observable stream, and then it'll apply the flat map concurrency idiom twice. First, to download all the pages of images in parallel, rather to download all the images in parallel, and second, to apply the flat map concurrency idiom to convert the stream of downloaded images into a stream of images that are transformed in parallel. So let's take a look now at download image async, which asynchronously downloads and returns the image at the given URL. And this method should call the get or download image helper method, as well as use the observable operators like from callable, subscribe on, compose, and the map not null observable transformer. This is a helper method that's statically defined later in the class, and it must be used in conjunction with the compose operator from RxJava. And this method performs the following steps. It first uses a factor method to create an observable that emits the URL. It then runs the computation in the IO scheduler. And then finally, it uses compose and map not null to map the image URL to a possibly downloaded image. Next, let's take a look at the transform image async method, which applies the current set of crawler transformers on an image parameter and returns an observable stream of all successfully transformed images. This method should call the create new cache item and apply transform helper methods, as well as use the observable operators like from iterable, filter, subscribe on, and that map not null observable transformer we talked about before, which is defined down below, and it should be used in conjunction with the compose operator from RxJava. This method should perform the following steps. Use a factor method to convert the list of transforms into an observable stream of transforms, run the computations in the IO scheduler, only transform images that have not already been transformed, and then finally apply the transform in the image using the compose and map not null methods that we talked about. Now, as you can see here, there's a call to run remote transforms, which you can just ignore for the purposes of this assignment. And likewise, you can ignore the transform image remotely method. Down here, you can see the method that's called map not null, which can be passed as a parameter, an argument to the RxJava compose call, and this will cleverly skip any null values that are generated in an RxJava stream. And this is necessary due to the semantics of RxJava in their handling null methods. And there's also an error handling method down here below that you don't really have to think much about because we do this for you, but it handles exceptions that might occur when your program runs. So those are the key methods that are defined in the RxObservable crawler class. There's a couple more things you need to do, however. You need to go back and you need to retrofit your parallel stream crawler implementation from assignment number 2, and you'll also have to retrofit your completable future crawler implementation from assignment 3. And what you're going to need to do is you're going to need to copy and paste all of the code from your previous solution. However, be careful when you do this because there's a couple of methods that are now added at the bottom of both of these files. And one method is called call in managed blocker, and you have to implement this to use the blocking task call in managed block method to run the supplier as a managed blocker. And then you also have to implement another method at the bottom of this file called managed blocker download image, where once again, you need to use the call in managed block method, which is up here, and the download image method to download the item in a managed blocker. And this should probably say call in managed blocker, not call in managed block. But basically, you need to implement both of these methods in completable future crawler, and you're also going to have to implement both of these methods at the bottom in your parallel streams crawler. And so we've retrofit the code in order to make sure that that works properly. You'll also need to retrofit some of your existing implementation code. For example, in completable futures crawler, you'll need to add a call to call in managed blocker in the appropriate place in the get page async method. And likewise, you need to update the process images method to make a call to manage blocker download image in conjunction with get or download image async. Likewise, in your parallel streams crawler file, you'll need to change the process image method to add a call to manage blocker download image in the appropriate place. And then finally, in the crawl page method in parallel streams crawler, you need to update the code to make a call to call in manage blocker in the appropriate place when you download the HTML page associated with a page URI. And the reason we're doing this is there's a much more clever way of being able to ensure that all blocking operations will run in the context of the managed blocker mechanism in the common fork join pool. So be careful not to just blindly cut and paste your code from assignments 2 and 3 and just paste them willy-nilly in here because your code will not work, it won't compile, and your tests won't work because you have to make sure that you integrate those other methods. And this, of course, is intended to mimic what happens in the real world where you have to be able to provide backports to code that evolves over time as new features and new capabilities become available. So this is just giving you a taste of what it's like to work on software projects that have to live for a long period of time. So that's the end of the walkthrough of the source code portions in the skeletons for assignment 4A. So now that we've walked through the specification and the skeletons, let's try to run the autograder. To do this, you click on the Gradle tab, then you click on the Crawler 2022 tab, then the Task tab, and finally the __autograder___ tab, and then you'll click on Run Autograder. And as you can see, what this will do is it'll go ahead and build your project and then run the unit tests. The first time that you do this, it may take a while because it takes a while to compile your code. Subsequent times should be a bit faster because it will have built earlier. So you can see it's cranking away, building everything, and momentarily it'll run the tests. Please note that you have to run the autograder and have that in your repository. Otherwise, I won't review your submission. As you can see here, the grader's running, all the tests are passing, which should be no surprise because I wrote the program. So you can see that we had 62 tests and 62 tests passed and no tests failed. If you want to see the output of this, go ahead into the project files view over here in the window and click on the grade file. And as you can see here, it shows that I completed 62 of 62 tests successfully. If I'd failed some tests, then we would have seen some diagnostics in there. So please make sure that you run the autograder prior to pushing your submission for assignment 4A.